Hey students, welcome. Thanks for joining. For today's session, the topic we're covering is factoring polynomials. So factoring polynomials. And I'll say and finding roots. And finding roots. The x values of the function. So here, let's look at our first question. Have paper and pencil ready. Take notes, take down the question. Here, so this is number 1 from the sheet that I've shared. X to the 4 minus 5x squared minus 36 equals 0. Okay, so I'll have that written down. And let's begin. So when we're factoring polynomials, we want to be on the lookout for any special patterns that we recognize that'll help us break this down into more factors that we probably could even further factor. So let's just look at this. So this is almost set up like a quadratic, but where we have like x squared plus x plus some constant c. But this is to the 4th power. This is to the 2nd power. But your method for factoring something like this, it would be the same for this. So I'll show you how I would walk through that. I look at, here, let me put some labels on this, A, B, C. And I'm just pulling that from ax squared plus bx plus c. Standard form for a quadratic function. This is my A, this is my B, this is my C in this case. And to get these two new factors, here, I'll write that smaller, just as a little side note. Standard form quadratic equation. So yeah, to get these two factors, I'm looking at A times C, and this A is referring to the coefficient on x to the 4. So it's referring to this 1 that we know is there. So A times C, I include this negative sign with it. Here. A times C, 1 times negative 36 is negative 36. And I'll look at the factors of 36. That will sum to give me this middle term, to give me negative 5. Negative 5. Don't leave out this sign. So here, let's list out the factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and boom. 4 and 9, that could give me 5. Which needs to be positive, which needs to be negative to get negative 5? Because again, these factors, they multiply to negative 36. So one of them is negative. And which one will that have to be to add up to negative 5? It'll have to be negative 9. So these are the factors of this. These are the terms in these new factors. Positive 4 and negative 9. And we need to get back this x to the 4th. So that's x squared, x squared. So we've gone from this standard form into factored form, but we can still factor. We have x squared plus 4x squared minus 9. Here we have our difference of squares. Here's your side note for that. Difference of squares, where we say, here we're given a squared minus b squared. Maybe I'll change up these colors so we don't mix up which I'm talking about. So this is a squared, this is b squared. And that can be rewritten as a minus b and a plus b. So this becomes a, which is x, minus b. This is b squared. So b squared equals -9. I'm sorry, just 9. So b equals 3. And we have a minus b, a plus b, x minus 3, x plus 3. Here, and just in case this was a little unclear, this factor looks like x, and I'll write it in a different color so it's not mixed up with our work. This is x squared minus 3 squared. That's why this is my a and this is my b. A, b. One's minus, one's plus. That's our difference of squares. We're subtracting two terms that are perfect squares. So that's why we can factor this like that. Here we're adding. So we don't have a special pattern for sum of squares. That's going to give us two factors. So okay, let me bring that down. Or let me rephrase and not say we don't, not that we don't have a sum of squares formula, but we don't want to use it here. So here, let me just bring it down. X squared plus 4 still equals 0. So from here, though, we have these 4 factors where if this was 0, if this was 0, if this was 0, if any of these factors in parentheses were set to 0, we could solve for x. Because if this was 0, multiplying it by these two factors, it would be 0. If this was 0, multiplying it by these two factors would be 0. That's why we set it equal to 0. So from here, we could do that. Back here, we couldn't do that. That's why we factor it. So we could get it into factors that where one, if we multiply it out, that one factor equaling 0 will make the equation equal 0. So now we could say, yes, x squared plus 4 equals 0, x minus 3 equals 0, and x plus 3 equals 0. Yes, I just set these factors equal to 0. And now we'll solve for x for each equation we just created. So we're just doing inverse operations to isolate x. And let's start with moving 4 to the other side here. So we're saying x squared plus 4. To get rid of this 4, from the left-hand side, we're going to subtract, and it's gone. We'll subtract to the right-hand side as well. So now we're left with x squared. That's gone. Bring down equals, bring down -4. And we want just x, not x squared. So we have 2 x's right now. We can take the square root of each side. So square root of x squared equals the square root of -4. Taking the square root of this, that'll get rid of that exponent. And we're just left with x. But over here, we have the square root of -4. Here, so let me rewrite that first. I'm going to rewrite this into, into two factors, one of which we know has a perfect square root. So I'll rewrite this as 4 times -1, because I just want the -1 to remain under the radical. We could take the square root of 4. So the square root of 4 is 2. And then we're left with the square root of -1. But we don't take the square root of a negative number. But we do have a value for this. So another sidebar for your notes. Our imaginary number I, equals the square root of -1. So this isn't, we're not going to leave this as 2 root negative I. We're going to say this is x equals 2 times the square root of -1, which we said is I. But let me rewind. Hold on, I skipped one thing. So back here, way back here, when we first decided to take the square root, when we were trying to get x all by itself here, when we take the square root, we're going to have a positive answer and a negative answer. So yeah, this is all plus or minus, plus or minus, plus or minus. So x is plus or minus 2i. So we have x equals positive 2i, x equals minus 2i, negative 2i. And that's our third root. Oh, yes. I was adding up. So looking back, we had a polynomial of degree 4. We know this is a polynomial of degree 4 because our exponents for the polynomial, they're in descending order. So 4 is the highest degree. So this determines the degree of the polynomial. So the degree, here, should I put that as a note? Highest degree, I'm sorry, highest exponent determines the degree. So, and the number of roots. So polynomial of degree 4 will have 4 roots, and that's what we had here. We had x minus 3 and x plus 3. Oh, I'm sorry, I didn't solve these yet. But we found these two, and now here to do the math here, we're just getting x by itself again. So moving this -3 over on from the left, we have x equals 3 now. And subtracting 3 from both sides, if x equals -3. So these are our 4 roots. Okay. So this was just the first walkthrough through a problem like this, but this is the route that you would go on any similar problem. Yeah, just a quick recap. The first thing is we need to, a lot of times we'll need to recognize these patterns. Recognize, oh, I could apply how I factor a quadratic formula to this. Or, oh, this is my difference of squares. I know how to break this down into its 2 factors. Or, hey, I need to stop here. I don't need to go any further factoring. At this point, I could set everything equal to 0. Even if we didn't do this, let's look at that real quick. X squared equals 9. X equals plus or minus 3. Yeah, even from here, we could have said x squared equals 9, and then we would have got x is plus or minus 3. But yeah, I think either way would have worked. Here we applied our difference of squares, but we could have also set either factor equal to 0 and solve from there. But just once we did that, with this factor, remember, once we set it equal to 0, we ended up taking the square root of a negative number. One, when we're taking the square root, we're going to have a positive and negative answer. And then secondly, if we have the square root of a negative number, we'll break it down into its factors until we just get the square root of -1 left under the radical. So we could express our answer in terms of I. So that's a mouthful, a pretty lengthy process, but yeah, take it all in, have it all down for your notes. And yeah, try it on your own again another time. Let's hop into another one. Yeah, let me rewind. Before we move on, I actually want to show you what are we solving for? What do these x values mean? What are roots of a polynomial function? So just, you should have this down. We had x equals 3, x equals -3, x equals 2i, x equals -2i. So I'd like to show you what those are. So here comes our graphing calculator. Okay, there we go. That'll speed things up. Our function was x to the 4th minus 5x squared minus 36. Let's try to get this a little bit more in view for you guys. Let's do y to -80. Oh, that's my x. I to -80. Okay. So what are the roots that we just found? We just found two real roots that actually cross the x-axis. So our roots cross the x-axis. That's why they're x values. They cross here, y is 0. Y is 0. So those are the two real roots we found. But again, this is a polynomial of degree 4. So why don't we see two more places where our graph is crossing the x-axis? Is because those two other roots we found, x equals 2i, x equals -2i, they're complex roots and they don't appear on the graph, but we need them to make this equation true and to get down to all 4 roots of the equation. So when you're finding the roots of a function, you're finding the x values where the graph crosses. So this is what you would be graphing if you have roots. You're graphing this point on the x-axis. If it's a complex number with our imaginary number I, we cannot graph those in this xy plane. But they will, the sum of the roots between your real roots and those complex roots will equal to the degree of this function. So yeah, I just wanted to point that out before we move on. So